I'm going to move over to the document camera. You guys have a test on Wednesday.
Yeah.
And it's over forces and energy. So if I were making my cheat sheet for this test, I would include my kinematics equations, because there's going to be times when we're going to have to figure out acceleration. So I'd make sure those equations were on there. I'd make sure that F is equal to G M1 M2 over R squared is on there with the value of G, which is like 6.67. But I'd make sure that that was included on my sheet, because you never know if that's going to show up. We've got Newton's second law. It's the sum of the forces, and this is going to give me my net force is going to equal mass times acceleration. So I would make sure those are on there. I would make sure that my potential energy is listed. I'd make sure my kinetic energy is listed. I'd make sure I'd have my force due to friction is listed. I'd make sure my spring force is listed, and my potential energy due to springs is listed. Because basically what this test is going to cover is Newton's second law, Newton's laws, applications of Newton's laws, and conservation of energy. The other thing I may want to keep on my table, just so that I have it, is I've got, this is R, this is X, this is Y, and have my equations associated with those. Because the big thing we got to remember is that vectors have direction and magnitude, and we've got to keep track of those, and my force is a vector. So you might want to go back and review vectors. You'll also want to make sure you have work on here. This is the full version for work. But the big thing is that our force has got to be in the same direction. Okay, force has got to be in the same direction. So, these are the things that I would make sure I would have on my cheat sheet. But remember, your cheat sheet, you can have anything that you want, as long as it's on an 8.5 by 11 sheet of paper, and it is in your own handwriting.
So what is G?
It's like 6.67 times 10 to the...
Yeah, to the negative 11.
10 to the negative 11, yeah. That's why I said I could make, there are certain big numbers I remember. G is not one of them.
Yeah. I just was trying to find it, and now I ran on it.
Yeah.
Symbol on it.
Yeah, so I just make sure it's there. Okay? All right, so that's what I'd make sure is on my cheat sheet. Things that I would review. Vectors. Be able to calculate tensions. And what I'm actually going to do today is I went through and looked at web assign to see which problems were the ones that more people had trouble with. So we are going to do the leg problem today. We are going to do the suitcase problem today. Those are the two that typically people have trouble with. We also are going to do one that has multiple masses to look at tensions. So we will actually look at that. You want to be able to calculate force from a variety of different means. You know, if you're given, you want to find the stopping force of a car, for example, and you're given that the car takes 20 meters to stop in a certain time, you're going to have to calculate acceleration and then calculate the force. So go back and look at the quiz type problems. Look at the extra problems that were assigned just to help you guys out, the ones that are for practice. Those would be good places to look, but you're going to want to be able to calculate force from a variety of different conditions. You want to look at work and be able to calculate the work given certain aspects. I'm getting ready to do the loop-to-loop problem to kind of look at that part of it. You want to look at conservation of energy and be able to use it. You may have to include friction and you may not have to include friction. So a good review problem would be to go back on Wednesday's class when we did the block that went across a rough spot that hit a spring. That combined everything that we've been looking at. So that would be a good review problem to have. You want to be able to look at Hooke's law. Oh, the other one that you want to have is power. And power is energy divided by time, or power is work divided by time. And I will help you set up the eardrum problem. I'm not going to do it for you because you got until 6 p.m. tonight, but I will help you set that one up. Okay? Because the homework's due at 6, so if you haven't got your homework done, you have until 6 p.m. tonight to get your homework in. And I will help you with the eardrum problem. I'll get it set up. So you want to make sure you have power on your cheat sheet as well. The test covers chapters 4 and 5. So it's covering forces and energy. And don't forget, you've got quizzes due, and the quizzes are staggered. So I think there's one due tonight, one due Monday, and one due Tuesday. Again, to help you out. All right. So let's do the loop-to-loop problem. So I have a loop, and we're going to start off at a height h, and in order to make the loop, the force up here has to equal mass VR, or V squared over R. Okay? And I showed you the video, the Pepsi Max video, of the guy doing it, and the gal calculates it, says it has to do with the centripetal acceleration, but the force at this point has to equal, the magnitude has to equal mv squared over r. If this r is going to be our radius of our loop, the question is, how high do I have to start in order to get through this? So, in this point, we're going to have potential energy, which is mgh. At this point, we have kinetic energy plus potential energy, and the kinetic energy is going to be 1/2 mv squared plus 1/2 plus mg2r. So in this case, I'm going to solve for v squared. V squared has got to be the force times R divided by M. But the force has got to equal the weight of the ball. So this just becomes mgr over m. This just becomes gr. So the velocity that I have to have is just going to be gravity times r squared, or the velocity squared. So using my conservation of energy, mgh has got to equal 1/2 mv squared, which is plus mg2r. M's all go away. I'm going to solve for v squared. Okay. So I've got GH is equal to V squared over 2 plus 2GR. I'm going to multiply everything by 2, so I get 2GH is equal to V squared plus 4GR. V squared is equal to 2GH minus 4GR. But that's got to equal GR. G's all cancel. I'm going to solve for H. So I get 2H minus 4R is equal to R. H minus 4R is equal to R, so I get H, or 2H is equal to R minus 4, or plus 4R is going to give me 5R, 2H. H has got to equal 5/2 R. In order to have the ball make the loop, or the Hot Wheel car make the loop. Alright, so let's take the eardrum problem. The problem tells you, gives you lots of information. Okay? Problem gives you lots of information. The thing that it's telling you, the big thing that it's telling you is this. I've got a speaker, and it's going to send out sound. And sound's going to disperse like that. And if you think about it, is if I have a sound source, sound actually goes out as a sphere. And you're told that the intensity of this sound is going to drop by 1 over 4 pi r squared. So the further away I am, it's going to drop by 1 over r squared. This is the same principle that when we look at F is equal to G m1 m2 over r squared. As I move away from the surface of the earth, this falls off as 1 over r squared. Same thing here, this falls off as 1 over r squared. So we're told that this has got whatever weather sign gave you, like this is 1.6 watts at that point. We're told that it's going to decrease as 1 over r squared, and then we're told that if I'm looking at my speaker here, I've got my ear over here, So we'll use an elephant ear because I can't draw a person ear. So we've got this, and we're told that we have an area here, and it's in centimeters squared, that can be damaged if we hit 10 to the minus 6 watts. It also gives you information that if you have an extended amount of time at 10 to the minus 4 watts, you can damage your hearing. It's actually a piece of factual information that's trying to get you, A, not to listen to headphones at high volume, and B, not to stand right in front of the big speakers at a rock concert. Okay? That's basically what that is trying to convey. Basically, that's trying to convey. So, if I use this information that my power is going to decrease, so my power is going to decrease by 4 pi r squared, and I get damage at a certain power over a certain area, I'm setting up a ratio. And so that's power 1, that's power 2. You're given your area. It's asking you for your distance away. You're solving for R. You will see this again in Physics 2. You see this again in a lot of different things. And for those of you who are healthcare providers, this is why OSHA sets the standard at 90 decibels for an 8-hour day. Its action level is 85 decibels, which means that if you are raising your voice in order to be heard over a piece of equipment, you need to be wearing hearing protection because you are permanently damaging your ears. And it only takes a one-time shock. The Inuits in Alaska, who live in an extremely quiet environment, tend to have deafness because of the extreme power that hits their eardrum, and their eardrum isn't resilient enough because they live in an extremely quiet environment. So if they're not using hearing protection when they fire the rifle, they have a tendency to lose hearing in that particular frequency of the rifle. So you do get it, and once you've lost it, you've lost it. Zebrafish, however, don't, which is why people are studying the hair cells in zebrafish, because zebrafish can rejuvenate their hair cells. And people, you're born with them, and if you lose them, you lose them.
Well, isn't the other issue because of that little bone that keeps the membrane for your eardrum stabilized? It tends to break as well.
That's a different type of deafness. That's not going to be associated with this particular situation. But that's another one that can happen.
It's fun knowing behind why I have tinnitus. So.
Tinnitus is a whole different issue too. It's a whole different issue too. And what's also interesting, everybody, since I've got a lot of biology types, how many of you take an anatomy? Okay, you all know you have rocks in your head, right? The rocks in your head, those are calcium carbonate crystals with proteins. They actually help to stabilize balance, and in fish they also help to have the ear for them to hear. But those can get out of alignment and makes you dizzy and can cause vertigo. So you have some interesting physiology stuff with the ear. The ear is very interesting. And It's mostly physics. Sorry guys, the ear is mostly physics. Okay, so you all had a problem where we had two pulleys. And off of this pulley was 100, I'm going to use the 110 Newton weight. Comes down here, comes up here, and we have the weight of the person's leg over here. And the idea behind this contraption is to take the weight off of the hip joint while a person's in a cast so that they can have their bones healed properly. And we're told that this weight, I'm going to use 357 newtons, is the weight that we're trying to get. And we're told that this is a 40-degree angle. We're not told what this is, and we don't know that weight. So your physical therapy type guys, this is a perfect problem for physical therapy, because this is exactly what you're trying to do for physical therapy, is trying to maximize those. So essentially what you have in this case is an equilibrium problem where we have the tension in this one side, the tension in this side, balancing out the weight here. This is a 40-degree angle, and this is the angle that we're trying to find. Now, because this is a pulley, the tension in this cable is going to equal weight 2. The tension in this cable is going to equal the first weight. And your first likely mistake was as follows. Many of you went ahead and said, okay, I've got F is equal to mg, which is going to equal my tension, which is now going to be 110 times 9.8, and what the sign was going to go, Look at the units. I have newtons times meters per second squared. That is not a weight. That's something else. I don't know what it is, but it's not a weight. The problem gave it to you in weight. It gave you the force. So you didn't have to multiply it by 9.8. So on the test, look to make sure, are you given mass or are you given weight? Weight will be in newtons and pounds. Mass will be in kilograms or slugs. If I'm given mass and I have to calculate a weight, then I multiply by 9.8. If I'm given newtons, don't multiply by 9.8. It is a very common mistake because you get into the habit of multiplying, because you get in the habit of getting things in mass, not in weight. So that's the first thing about this particular problem. Second thing is you have to remember that the sum of the forces, and I'm going to write it out as my vector, has got to equal 0 for the first condition of equilibrium. I have no motion. I have no acceleration. I have no acceleration. If I don't have acceleration, I'm okay here. So I have no acceleration. So I'm going to do the sum of the forces in the x direction and the sum of the forces in the y direction. Sum of the forces in the x direction is going to be my 110 newtons. It's going in that way, so it's negative. And I've been given that angle, so it's going to be cosine of 40 degrees plus the weight that I'm trying to solve for, cosine of alpha equals 0. Sum of the forces in the y direction is going to be my 110 sine of 40 degrees plus weight sine of alpha minus the weight of the leg has got to equal 0. And in this case, this was given to us as 357 newtons. So now I have two equations, two unknowns. So what I'm going to do is I'm going to take the weight of cosine alpha is equal to 110 cosine of 40 degrees. I'm going to have the weight sine alpha is equal to my 357 minus 110 sine of 40 degrees. I'm going to go ahead and solve for numbers here. So I got weight sine alpha, weight cosine alpha. This gives me 286.3, and that's in newtons. This gives me 84.3 in newtons. I'm going to do a mathematical trick. I'm going to divide. If I divide, the weights cancel. Sine over cosine is a tangent. So I'm going to take my 286.3 divided by my 84.3. Gives me 3.396. And take the arc tangent. And it gives me the angle is 73.6 degrees. And once I have the angle, I'm just going to take the weight sine alpha is equal to 286.3. Weight is going to equal to 86.3 divided by the sine of 73.6. Gives me 298.4 newtons. Let's do the suitcase problem next. So we have our suitcase, and we've got a person pulling on a strap for our suitcase. We're told that the suitcase has a mass of 18 kilograms. We're pulling it with a constant velocity, and this angle is going to be there. We're told that she's pulling on the there's a force on the strap, and the force is equal to 38 newtons. And we're given that we have a force due to friction of 20 newtons. Okay? And we're told that this is a constant velocity. So if I draw my diagram here, I've got the force due to gravity. I have the force that's being applied at an angle. I have the force due to friction. and I have a normal force. So I can actually draw it like this. So this is my normal force, the force that's applied, force due to gravity, and my force due to friction. And there's an angle there. This constant velocity means that the sum of the forces, mass times acceleration, if it's a constant velocity, that means this is 0. So now, what I end up with is I'm going to go ahead and draw it in here in a different color. I have the force in the x direction. I have the force in the y direction. So now I can write my equations. The sum of the forces in the x direction is going to be the force in the x direction minus my force due to friction. This is the force cosine of the angle minus my force due to friction has to equal 0. So force cosine of the angle is equal to the force due to friction. Cosine of the angle is equal to the force due to friction divided by the force. I'm given that the force due to friction was 20 newtons. I'm given the force that I applied is 38 newtons. 20 divided by 38, take the inverse cosine. My angle equals 58.24 degrees. Wants to find the normal force. Sum of the forces in the y direction is going to be my force y plus my normal force minus my force due to gravity. My force y is 38 newtons sine of my 58.24 degrees plus my normal force, which is what I'm solving for, minus the weight, which now I have to do my 18 times my 9.8 because they gave it to me in mass. Solve for the normal force because that's got to equal 0. And the normal force equals 144 newtons.
Then 18.
Yep, because that was the mass. Times 9.8. Because it gave me a mass, I have to do 9.8 to find the weight. Guys good? Okay. So now we've got, and this will do one that we have to kind of find information from. So I've got a car that's traveling at the highway, 40 kilometers per hour. And we're given a coefficient of kinetic friction is equal to 0.118. And we want to know stopping distance. We want to know how long, if I slam on the brakes, what's the distance before I get to a velocity equal to 0. Okay? So we know that the force due to friction is going to be this right here. And if I take the sum of the forces in the x direction, it's going to equal my force due to friction, which is going to equal my mass times my acceleration in the x direction. Okay? So I'm going to need this acceleration. And if we go ahead and carry this out a little bit, I get mu k is equal to mg for my normal force. And so I can get minus mu k mg is equal to max. My masses cancel. So I can do mu kg, or since I've got force due to friction, I can leave this as minus the force due to friction, m is equal to our mu kg. So we can just play with it. But I gotta figure out my acceleration in the x direction. So we can do v squared is equal to v initial squared plus 2a times my change in direction. I have to convert 40 kilometers per hour. So it's 1 hour is 60 minutes. 1 minute is 60 seconds. And that's going to give me gives me 0.0111 kilometers per second. I'm going to divide by, or multiply by 1,000 to convert to meters, and it gives me 11 meters per second. So I got 11 meters per second. So if I do this, we've solved for AX here, and I can plug that in there. So I can do 0 is equal to 11 meters per second squared minus 2 mu kg times the distance that I'm trying to solve for. Because up here, it's a deceleration. My acceleration is equal to negative, and it's coming from the fact that it's a deceleration. I could have gotten it, I could have gotten it here directly, just because I've got my setup as my force due to friction. But we also know it's a deceleration, so I could have just plugged it in that way. You can get that that's a negative a couple of different ways. We know G, we know that. We're just going to solve for D. So D is equal to 11.2 squared divided by 2. My coefficient of friction, 9.8 meters per second squared. And this gives you 10.7 meters. Oh no, sorry. That was if it was dry road. This is, if it's wet road, it's 53.4 meters. And if I change this to 0.590, that's when I get my 10.4. This is dry road, that's wet road. Which is why your stopping distance increases on a wet day. It's also why at night you need to slow down, because you don't want to overdrive your headlights, so that when the deer finally hits and comes into your lights, you actually have time to stop. Because if you look at your stopping distance is 10 meters, and you think about how far your lights actually extend out, it doesn't give you a whole lot of reaction time plus stopping distance, so in order to not hit the deer. Now that doesn't do you any good if the deer hits you. I kid you not. I've had the deer jump on my hood. I have stopped in plenty of time, and the deer still goes, nope, pat, pat, pat. And if you drive into the state of Maine, the sign says aim for the hindquarters. I kid you not, you hit the border in Maine, and it says moose are prevalent, aim for the hindquarters. Because you do not want a moose in your windshield. It's not a pretty sight. And that it's a big sign as you drive into Maine. Across the border, it says aim for the hindquarters, and it has a picture of a moose, and it says aim for the hindquarters.
I didn't get that calculation.
Should be 11.2 squared.
Well, that was 11.1.
11.1 squared divided by 2 times 0.118 times 1.8.
And
That's 53.4. And then when you do it with
is it 0.59?
0.59 is going to give you 10.4.
Oh, it is the 0.118 is the 53?
0.118 gets you 53.4. The 0.59 gives you 11.4.
I still come up with something different. I got 71.2.
Probably punching in the calculator wrong. All right, we'll do the glider one. The glider problem. And then we'll call it a morning. So we have the little glider back here behind the big plane. And we got tension in the rope. The glider is 250 kilograms. The plane is 1875 kilograms. And we're given that the acceleration is 2.20 meters per second squared. We want to find the magnitude of the thrust. For every action, there's an equal but opposite reaction. So the sum of my forces is going to equal my mass times my acceleration. And that's going to end up being my thrust. The trick here is that this mass, for this whole situation, is the 250 kilograms. The 1875, 250 plus 1875 kilograms, which is going to give you a total of 2125 kilograms times my 2.2, which gives me 4680 newtons. If I want the tension in the rope, that's the summation of forces there, and now this is just the mass of the glider times the acceleration, which is going to be my 250 kilograms times my 2.2, which gives me 550 newtons. So the key is draw your picture. Same rules apply on this test as in the last one. If you show your work, draw your pictures, you have the opportunity for partial credit. Drawing a good picture helps solve the problem. Getting your equations written down, that helps solve the problem. And it gives you the opportunity for partial credit for those problems that partial credit is available for. I do have several problems that partial credit's not going to be available for, but that helps it out. Question?
Did you say the test was Friday?
No, Wednesday. This is Wednesday.
No,
Yeah.
because it's fall break.
Yeah, Friday, I can't take the test on Friday. Now, for those that, because of PLC, sports, whatever, and has to take it at the testing center, I should have the test available at the testing center as of Monday, and it has to be taken before Friday. That's probably why you got the Friday card. Yeah, it had, but I meet, and then I have also made arrangements over in Tonkawa, if you want to take for the PLC guys, if you want to take the test, Tuesday, you can come by my office and take the test Tuesday.
What test is this?
Huh?
What test is this?
The test over chapter 4 and 5, next Wednesday. But I have a lot of people that, because of various things, will not be around next Wednesday. And so I will have it at the testing center so that you can take it there. But if you're over in Tonkawa, you can come by my office and take it. No, just one side of the page, 8.5 by 11, yeah. Yeah, and I should have it over the testing center probably for Monday morning. No, it's on the 16th. You want to take Tuesday? Okay, what I'll do, I'll have it over at the testing center first thing Monday morning, because it's on the computer, it is with me on my disk. But, actually, I can probably drop off some copies with the testing center today, so. Well, you have to set up the time with them, because you do a test, do a, go on and you do a
That's what she said.
If you
or whatever, and it's right on the copy if you get into a blackboard. It says how to set up
I
the
hit
time.
you 3 big problems in like
Yeah. So how many I got to use?
I won't really spell anything, but you might see my first one.
Okay, so I need to take 3 over there. Okay, got it.
It has to be one.
I can handle that.
In your handwriting. She said it.
It's floating around somewhere.
That way you can't just go online and like print off somebody else's.
Well, it'll be 2:30, but, you know, if, is that, okay, it'll be 2:30. Huh? Yeah, it'll be 2:30 today for those over here, because we have a faculty meeting at 1:30.
I need to study.
Yeah, we'll meet at 2:30 because I have a faculty meeting at 1:30.
I'll be there.
All right, you'll be there?
Yes.
So all right, so I'll definitely be there. I'll definitely be there then.
Hey, whose lab gets factored into our grade?
I have asked Dr. Salomanu to get me you guys's. I have already factored in the ones for the Tonkawa folks. I just haven't gotten them from Dr. Salomanu yet.
That's fine.
Yeah, as soon as I get it, I put it in.
Alright.
It's not my pen, it's somebody else's pen.
Can the cheat sheet be can it be typed or just have to be printed?
It needs to be handwritten. I have a reason for that. Because it helps you remember it.
One of the-
He's gonna